Random numbers. A tour of C++, concurrency and utilities. Random numbers are useful in many contexts, such as testing, games, simulation, and security. The diversity of application areas is reflected in the wide selection of random number generators provided by the standard library in Random. A random number generator consists of two parts: an engine that produces a sequence of random or pseudo-random values, a distribution that maps those values into a mathematical distribution in a range. Examples of distributions are uniform int distribution, where all integers produced are equally likely, normal distribution, the bell curve, and exponential distribution, exponential growth, each for some specified range. For example, using my engine equals default random engine, type of engine. Using my distribution equals uniform int distribution, type of distribution. My engine the default engine. My distribution 1 to 6, 1 to 6, distribution that maps to the ints 1.6. Auto die equals bind, 1 to 6 make a generator. Int x equals die, roll the die x becomes a value in 1:6. The standard library function bind makes a function object that will invoke its first argument, here, 1 to 6, given its second argument, here, as its argument. Thus a call die is equivalent to a call 1 to 6, Thanks to its uncompromising attention to generality and performance, one expert has deemed the standard library random number component what every random number library wants to be when it grows up. However, it can hardly be deemed novice-friendly. The using statements makes what is being done a bit more obvious. Instead, I could just have written auto die equals bind, uniform int distribution, 1:6, default random engine. Which version is the more readable depends entirely on the context and the reader. For novices, of any background, the fully general interface to the random number library can be a serious obstacle. A simple uniform random number generator is often sufficient to get started. For example, randint rnd, 110, make a random number generator for 110. Int x equals rnd, x is a number in 110. So, how could we get that? We have to get something like die inside a class randint. Class randint, public randint, int low, int high, dst, low high, int operator, return dst, draw an int, private default random engine uniform int distribution dst. That definition is still expert level, but the use of randint is manageable in the first week of a C++ course for novices. For example, int main randint rnd 04 make a uniform random number generator. Vector int histogram 5 make a vector of size 5. 4 int I equals 0, I not equals 200 plus I plus histogram rnd fill histogram with the frequencies of numbers 0:4. 4 int I equals 0, I not equals mn.size, plus I write out a bar graph. C out I divide T. 4. Int j equals 0, j naught equals mn, I, plus j, C out multiply. C out end L. The output is a reassuringly boring, uniform distribution, with reasonable statistical variation. There is no standard graphics library for C++, so I use ASCII graphics. Obviously, there are lots of open source and commercial graphics and GUI libraries for C++. But here I'll restrict myself to ISO standard facilities. Thank you for watching. Don't forget to subscribe.